All right, today we're going to be talking about Chapter 1, Lesson 9. This is all about estimating roots. So there's kind of a three-step process that we're going to take in order to do this. But essentially what we're going to do is we're going to be estimating to the nearest integer. So the first thing that needs to be done is we need to identify the two perfect squares that a root falls between. So, for example, if I'm looking to estimate the square root of 5. If I look on that sheet that you guys have, 5 falls between the square root of 4 and the square root of 9. 4 and 9 are both perfect squares. Next thing that we're going to do is we are going to put those numbers on a number line. So we would have a number line like this, where the square root of 4 is 2, the square root of 9 is 3, and then square root of 5 is closer to the square root of 4 than it is to 9, so 5 would be closer over here to 4. And then the last part is whichever perfect square our number is closest to is the estimate. So because the square root of 5 is closer to the square root of 4 than it is to the square root of 9, 5 is closer to 4 than it is to 9, that means the square root of 5 we can estimate as about 2. This symbol here means about equal. A lot of times that symbol is used when we are estimating an answer or rounding an answer. So, example 1. It says estimate the square root of 54 to the nearest integer. Now, if we look on our perfect squares, 54 falls between 49 and 64. Square root of 49 is 7. Square root of 64 is 8. So now I put those numbers on a number line, and 54 is going to be in between these two numbers. But square root of 54 is going to be about here. Because 54 is 5 away from 49 and 10 away from 64. So it's going to be closer in this direction than it is in this direction. It's closer to 49 than it is to 64. So the estimate would be square root of 54 is about 7 because 54 is closer to 49 than it is to 64. So the best estimate, rounding to the nearest integer, it would be about 7 because 54 is closer to 49 than it is to 64. Example 2, now we're dealing with cube roots. Same exact process. 100 falls, between 64, the cube root of 64 is 4, and 125, because the cube root of 125 is 5. Now, I need to figure out where 100 goes. So, 64 and 100, there's a difference of 36 there. And between 100 and 125, there's a difference of 25. So it's going to be kind of in the middle, but closer to 125 than it is to 64. Now, because we're rounding to the, or estimating to the nearest integer again, this is going to be, the cube root of 100 is about 5. And again, because 100 is closer to 125 than it is to 64. So because 100 is closer to 125, well, the cube root of 100 would be close to the cube root of 125, which would be about 5. In reality, this is probably about 4.6-ish. But the estimate we would say is about 5. Now, last example. It says to estimate the time in seconds it will take an object to fall h feet. You can use the expression the square root of h divided by 4. So about how long will it take to fall 38 feet? So in this example, what we're going to want to do is actually figure out which number 38 is closest to as far as the square root goes, and then utilize that number to help us estimate the time. So, same exact process. We're going to create a number line. 38 is between 36 and 49. Square root of 36 is 6. Square root of 49 is 7. Square root of 38 is really close to the square root of 36 because 38 and 36 are really, really close to each other, while the square root of 49 is kind of a distance away. So the square root of 38 is going to be about 6. Now we're going to use that number to help us solve this expression. So the square root of h over 4, that's the square root of 38 over 4, because we're looking for 38 feet. This is going to be about 6 over 4, because the square root of 38 is about 6. So it would take about, and this is that key word here, about, because we're estimating. 6 over 4 can be simplified to 1.5. So it would take 1.5 seconds, about, to fall 38 feet. All right, that is the end of lesson 9. If you have any questions, please let me know.